Um, this is for homework 5, question 2. So given the fxy equal to 1 over a times y squared x times x, y is greater equal to 1, and x is greater than 1 over y and less than y. So draw the non-zero definition region of fxy. So basically, that's okay. That this is x, this is y. So for this one, so we can see x is so we can see there's two parts. So the x is greater than 1 over y, and also x is less than y. So basically that's two functions, and I have already drawn this one. So x is equal to 1 over y. So basically this curve here, and the x is equal to y is this line. So basically, what we are trying to find is those part which is non-zero definition region is here, and also I will say the y is greater equal to the 0. So basically that's the graph. And for the second question, find the a so that fxy is a valid joint density function. So this one we need to do the integral, and basically we just do the integral for this part and compare it to equal to 1, and we can see like what's a value for that. So basically we are trying to do the integral here. It's from, since y is from the 1 to infinity, since y is greater to equal to 1, and for the x is here. So basically we do this first and do this and do this. So for the inner part, since there's integral about x, so we can move this part outside. Move this part outside. Move this part outside, and to easier our calculation. And here, there's a good way to find out some mistake, some typo. And for this part, we do the integral of the y over x, and we get natural log y minus natural log 1 over y. And after that, also we can see here, we can just pull out this part 2 over a. Since yeah, we just pull it out. And for this part, so that we will let w equal to log y, and since we can see here, that's why we do there's a 2 here is equal to so infinity 1 and a y squared. In this part, we just flip this and put the negative 1 outside, and we got, I will write it step by step. It's log y to negative 1 dy, and after that it should be infinity y y2 is 2 log y dy. So that's how we get the 2 here. And after that, we have y inside, and all the y inside in the integral. And we use w equal to natural log y and y equal to e to the power of w, and plug in for this part. So yeah, so it's for the E2W for the E, yeah. And after that, we just calculate this, and after that, we calculate here, and then the final formula equal to 1. So basically, just times here, and we got A equal to 2. So for the question 3, so find and draw the marginal density function for x and fy. So let's do the partial derivative for the function. So basically, for the density of y, we do the derivative of dx. So basically, it's x part, and we just pull the y part outside and do the integral of the y over x, and we already did in the last question when we try to find the a, and for this part we got the range, and we can draw this. To verify this, we got use this one equal to 1 compared to 1, it's equal to 1. So same thing here. This is between, we do it a partial derivative of dy, and for the density of x, and we can separate it from 0 to less x is greater than 0 less than 1. Since we can see here, it's easy to see for this thing is equal to 1. That's why we separate it. It's easy to calculation. And for here, it's or x and infinity. And there is x and infinity. So basically, that's 3 and 4 part of question.